one of the core subject of electronics and communication. So I hope all of you will utilize this opportunity to get at least some basic knowledge about these optical fiber devices and the applications. I thank once again all of you, and I request all of you to utilize this wonderful opportunity to learn something about the subject optical fiber devices and applications. Thank you, everyone. Thank you, sir. Thank you,
Thank
Gauri
you,
sir.
sir. Thank you, sir. So I will hand over to our today's guest here, Samir Singh. Shall we start, sir?
Yeah. Of course, of course. So shall I start, Gururaji? Shall I start?
Yes, sir. Yes.
Dixit sir, Dr. Dixit sir.
Yes, sir. Sure. You can start.
Okay.
Thank you.
First of all, I would like to thank you to everyone, and thank you to especially my college. I can proudly say it's my college which I studied almost 2 decades back. I was graduated. I'm also an alumni of this wonderful college. It was wonderful, and it is wonderful, and it will be wonderful always, as always. And so I was waiting for this opportunity. Earlier also we discussed, something technical seminar kind of a thing we have to do in the college. Since I am from a technical background, so I wanted to utilize this opportunity to share some of the knowledge. And well, my friend, actually he's my friend, Mr. Guru Raj. He's my friend, I can say. Since almost 25 years we are friends. See, especially this optical fiber technology. If someone want to indulge, or someone want to enter into this industry, the very basic thing what they have to understand is the concept. It's the concept of fiber optic technology. You need not have the core knowledge like how a fiber is constructed, what is the basic principle of light which propagates inside the core and carries the data or power inside it. Only thing that the concept, where it is applied, what is the application of this fiber optics, where it is used, what is the use of sending a light like that. So many things we will discuss. I have a slide. Of course, we'll discuss very brief. It's a wide, very vast subject. It's a very wide subject. In fact, cannot discuss it in a minute, a day, or a week. It goes on. It's endless. I have briefed everything. I made a very brief things of everything, which will help you in your future. Of course, when you graduate, when you pass out, and some of you may opt for a post graduation kind of a study, where you may opt for fiber optic communication or optical communication or a microwave or something related to this one. So this webinar may help. Maybe it may help 1 or 2%, and also see if younger semesters like second, third, fourth, 5, 6, they may not have the fiber optic as a core. Maybe in the higher semester 7 or 8 they will be encountering this subject. But whatever the things I will share, you might have learned. Some might have knows 99% what I am talking today. 99% of the things, yeah, I know this. Maybe 1% they might be knowing, which will be useful. Or some of the things which I am going to tell you, you may know only 1% of the thing. Maybe 99% of the things you may not be knowing. But at the end of the day, our ultimate goal is, I'll share some of the things. Just have a look at that one. Just to focus on what I'm talking. I have an experience of 21 years in this field, along with other core subject like RF systems and RF transmission, RF distribution. Fiber optics, of course, in last 1 decade, it is emerging as one of the fastest growing technology. So we'll begin. We'll begin this one with a slide which I have prepared to discuss with all of you. So because that will, so that slide contains some of the keywords which you may be, it may be useful for you to understand how this optical fiber is applied in real time situations. It may be a different sectors, or it may be a different uh, you know a public sector unit, or a defense unit, or a private unit, or a telecommunication. So in a different areas of specializations, how these optical fibers are used, or what are the alternative to optical fiber, or why optical fiber came, what was there earlier and why it has come, what is its advantages, we will see it in a slide. So as you can see, I hope everyone can see my slide which I am sharing. If anybody is not able to see, please contact Guru Rajji. So he will be helping out. I'm just sharing through my screen. If anybody is not seeing the screen, or unable to see the presentation, please contact Mr. Guru Rajji. He will be, working out this thing. I hope everyone is seeing. Guru Rajji, I think everyone is seeing, right?
No. Yes, sir.
So
No
it's
issues. No
visible.
issues. You can
Oh,
continue.
okay. Yeah. So I represent this company, Fibre Electro Systems, OPC. It's a one-person company. It's OPC is one-person company. I'm heading as a director, technical director of this company. Very brief, I'll tell you. We just deal, as Dikshit sir has said, we deal mainly with the defense systems like a DRDO, BEL, NAL, HAL, RCI, that is the Research Center Imarat, which is there in Hyderabad. And we have a tie-ups with some of the public sector units like BDL, that is Bharat Dynamics Limited, and this HAL, we have a partial tie-up. I mean, we're not full-time contractors to provide them the solutions. It's on case-to-case basis. So basically, we are into hardcore electronic equipment suppliers with technical supports. So our main aim is to educate, install, commission, and to make sure the working of the things which we supply to the defense organizations, they works fine under adverse conditions, like we basically make them rugged systems. Whatever we supply it in a rugged case where it can be used in a tank in a war, or it can be used in a very severe conditions like a minus 40 degrees centigrade, or plus 51 degrees centigrade. So it should withstand all those things. So these are the products which we sell to the public sectors which I have mentioned. The thing is, during this process of sending these equipments, installing, we do on-site, do visit on-sites, because it's not like that we can sell it to some of their offices and they are going to install. We personally go, we do installation of these things, we make sure things are working fine, we get the reports, we check it periodically whether the systems are working fine, we take the calibration report, we take the outputs, and we take care of the warranty what we have given that one, and all other technical support kind of things. Of course, fiber optics is also one of our core product line which we sell to the defense and other private organizations, research organizations. See, this webinar was organized focusing only, I cannot say only, but mainly on optical fiber, or fiber optics, at Guru Rajji said. Some of, not some of, I think final year students have optical fiber communication as a core subject with them. So this will be very helpful, because will not deviate anything other than optical fiber, because we have a lot of modes of communications are there. But our focus on this particular webinar will be on optical fiber communications. We'll start the slide. See, why, if somebody asks why optical fiber was used, there is a simple reason, because there were some hiccups or there were some obstacles in wired communications. Of course, only in wired communication. You can remember the word wired communication. I'm not talking about here wireless communication. Optical fiber is not a replacement for wireless communication. You please remember, like, this will help, of course, in your interview also. Optical fibers are also a wired communication fiber, but the wire will be in the form of a fiber, right? Optical fibers are alternative to wired communications, not wireless communications. So there were some problems in wired communications since 19th century till today. All our communications were dominated by wired communication, especially the copper wire, and in very rare cases, aluminum was used. And though wireless, it is still expensive way of communication. People preferred, because wireless was expensive, people preferred wired communication. The only reason was the expense. I have to spend more for wireless. That is why I'm going for wired communication, like that. That thinking was there earlier. Now it has been changed. There are a couple of things which wired communication has got disadvantages compared to the fiber optics. There are some magnetic interferences or bandwidth limitations. Magnetic interferences, such as if you lay communication cables or communication wires, I can say communication wires near high magnetic interference field, such as the HT lines or any devices which have magnetic presence in it, magnetic systems presence in it. So those things will affect the propagation of the data inside the copper cable. So that can be avoided in fiber optics. How it can be avoided? Of course, you will also study in your academics. But when it comes to industry, what are the precautions, or what are the parameters they check before achieving this interference-free, transmission of data? But we have to see. But just remember that wired communication has these two limitations, these two sufferings, or these two disadvantages: magnetic interference or a bandwidth limitation. So there is very low bandwidth limitations in copper compared to the optical fiber. Why? I will tell you in one of the slides why bandwidth was the problem in copper and why bandwidth is not a problem in fiber. I will tell you in the coming slides. The other problems with the copper wire transmission, or you can say, we'll not use the word copper wire, we'll use simply wired communications. Like the endpoint losses or a cost of a setup. See, endpoint losses means whatever you send from the source at the receiver, or you can say the end point, it may not be the 100% which you have sent through the source. So there will be some losses, and those losses are considerable. I mean, you cannot neglect those losses. Very simple language, if I want to tell, if I send 100 GB data, see, end point I am receiving 40 GB only. So there is a loss of 60 GB data in between in copper. So that is one of the disadvantage of wired communication. Cost of a setup, of course, it is high. If you can compare a 1 kg of copper and 1 kg of a fiber, in terms of kg only you can consider. Not don't go in technically, just in terms of physical weight of those things, it's costly actually. Copper is costly compared to the fiber optics. Low reliability. Why? Because See, copper, you can easily tap it. I mean, the information easily you can tap it. So there is a chances of malfunctioning of the data. You can you might have heard saying people that a phone tapping is there, or my telephone this thing has been cross talk is there, or line change is there, that kind of a thing. So the reliability is very low. I mean, I cannot rely on copper wire that it is 100% safe, that my data is private, or my data is safe from any tapping or any other obstacles. So that was the one reason, because it is under easily you can do malfunctioning. You can introduce malfunctioning in those kind of setups. The next one is the space. Like a space, you need a larger space to set up these kind of wired communication equipments. It occupies, of course, the space, whereas fiber optics are mostly underground systems, systems. Mostly, I can say mostly, say around 80 to 90% underground systems. So there is no question of occupying space. And last couple of things, inventory maintenance, which these are general words. You have to keep track of all the inventories, like what I have used, what kind of tower I have used, what kind of antenna I have used, what kind of cable, what kind of power supply or a measuring unit, and maintaining, of course, maintaining of those things, whether they are all working fine or not. So these are additional burdens when you use a wired communications. So as I told that in previous slide, that wired communication suffered due to some of the stated disadvantages. Optical fiber communication was invented. These are the features. I think you will study these things in your academics. Now the parameters which I am showing you is a typical telecommunication parameters. If for other applications, it may be higher than what I am showing you. The bandwidth is very high, up to 50 gigahertz, whereas in wired communication we hardly achieve anything 2 gigahertz or a 3 gigahertz bandwidth typically. I mean, and the loss is very low per kilometer. You can see 0.16 decibel you will lose, whereas if it is wired communication, it's quite high. It can go up to 70, 80, or 90s. It depends on the environment. It depends on the surroundings in which the cable or the medium has been installed. If it gets heated also, the losses or the attenuation will be very high. Immune to EMI. See, the key fiber optics are I'm skipping some basics, because how the fiber is constructed, all the things you might have studied in your academics. There will be a core, there will be a clad, there will be a jacket, and all the things. So immune to EMI means there is absolutely no interference of electromagnetic waves to the fiber optics cable. You can test it also. You can test it if you have a fiber optics cable. You create a electromagnetic interference in and around the cable. You will see your data is absolutely fine. Your data transmission is absolutely fine from source to the destinations. You will achieve 100% data transmissions. Whereas if same thing, if you do it with the copper cable or a wired communication cable, certainly there will be data corruption will happen during the transmissions. The next one is the data security. As I said, in wired communication, you can tap the information. The data which you are transmitting through the wired communication can be tapped. As I said, there will be a malfunctioning. I can insert some of the hacking things, and I can tap the data, and I can use it that data illegally. That's not an ethical. Whereas in fiber optics, it's absolutely safe. See, you cannot make a hole, or you cannot insert a coupler. You can tap the data, because everything is in optics. Everything is in the form of a light. So you can't do anything. Even if you tap it somehow, you can't do, or you cannot analyze that one. Whereas those things, electrical signals, which are passing through the wired communication, you can use it. You can decode it, or you can use it. There are solutions for that one, but this is of a no use. And even if you get tap the fiber optics also, that is why people say that it's almost impossible to tap. System costs are lower because for long distance communication, for wired communication, you need lot of repeaters, you need lot of amplifiers, and some of the places you need attenuators, or some of the places you need couplers, splitters, and so many things. And that too at a very short distance, say a 2 kilometer or 1 kilometer, you need repeaters. Because the efficiency or the signal weakens as it travels through these cables. You need an amplifiers, or repeaters in wired communication. So that will add to the cost of overall systems of data transmission. That will add the cost. Whereas in fiber optics, kilometers to several kilometers together. I mean, in fact, you can say one example, 100 kilometer, you need not have any repeaters or amplifiers, couplers, or a connector kind of a thing in fibers, because of its low attenuation, low losses. So that will save a lot of cost which you are incurring during the installations. The next one is the size and its weight. Size is very small. Of course, copper cable also, if you see physically, some of you might have seen copper cables in your home. If some of you have, this FTTH, fiber to home wires, you can see that there will be an yellow wire. You will say that no, the same yellow wire is same as the normal copper wire what we use in a telephone. No, actually, that yellow wire is an outermost jacket. That's a second jacket. But actual fiber is of in terms of micron. I mean micrometers. So I mean with the naked eye, it's very difficult to judge the size, judge the diameter of that fiber. Whereas copper cable or a copper wire, we can see it. So that is why we say that sizes are smaller. Fiber optics sizes are smaller, and weight is also very low. See, weight is low when we consider long distance communications. 100 kilometer means like I can say kg or tons of copper cable we require to lay it. So the weight will be very high. Whereas in fiber optics, the weight is very low. You can say you can reduce 1/50th or 1/60th of weight in terms of fiber optics. If it is a copper cable, the weight will be 50 times less if you use fiber optics. Bit error rate is very low compared to the wired communication. Bit error rate, I think in academic also study. Then just I will tell you in a very simple language, like I'm sending 100 bit data, and I'm getting 100 bit data at the output, but only one data is corrupted. So typically my efficiency is 99. So 99 data correct I am getting. One data which I am getting corrupted, I can easily find out and I can rectify it at the end. So that is a very simple definition of a bit error rate, but bit error rate has got a different technical definition when you consider an electronic field. But just to make you understand, bit error rate is the number of like the data which you transmit, how many data got error in receiver. Typically it is very low, like 0.000000001. I mean 10 is to minus 10. So that is also a reason where fiber optic communication or fiber optic cable was preferred over wired communication. Uh, the last one is the reaching the remote places. Yeah, reaching the remote places, lying off this cable. You see, some of you may say that, sir, even copper cable also can go for a long distance. Why I have to use a high cost optical fiber? The reason is very simple. Uh, See, once in a remote places, a hilly area or a very high dangerous terrains will be there. In those places, a person cannot go regularly and check the fault. Okay, so if you lay optical fiber, of course, the initial cost of the laying of optical fiber communication will be very high, but once it's done, so you can forget it's 15, 20, 25 years, there won't be any problem. Whereas if you use a wired communications in long distance, or as I was saying, in a hilly area, or very rigid terrain conditions, uh, there has to be someone who should continuously monitor those things, and it will be very difficult for that person or a team who is taking care of these things. They have to travel across this very weird kind of geographies and check the functioning of these systems. So here, this is a very advantageous for fiber optics communication things to be used instead of wired communication. Mostly, even our government also, our Indian government also, especially DRDO, they have, I mean, they have done this thing, this kind of system installations in Ladakh, as well as in Sikkim. They have done. We have done in Silchar also, Assam. I myself has gone there. Assam also we have done fiber optics commission. The only reason is this: it's a remote places. You cannot go again and again. If it's a fiber optics, means you can go once in a while. That's it. So you can save time, save energy. You can risk free it is. That is the reason where these kind of systems, or you can say the fiber optics communication systems, are replaced wired communications. We'll go further. Mostly all of you know, you see, nowadays everyone knows types and applications where it is used. But I'm listing very hardcore fields or hardcore industries where fiber optic communication is, or fiber optics devices are used. The first one is communication and telecom applications. Uh, okay, telecommunication and communication appliances, primarily single mode fibers, SMF, that is single mode fibers. Uh, see, see, this is a very typical thing. If somebody says where a fiber optics used in telecommunication, some of you might say that, no, I have a FTTH in home, fiber cable is there. Of course, yes, but everyone carries a fiber optics device nowadays. Everyone carries a fiber optic device nowadays. Why? Because the fiber optic, the word itself is a dual word. First one is a fiber, and the second one is a optics. So fiber is nothing but a medium. It's a path. Fiber is nothing but a path or a medium. Optic is nothing but a light. So light passing through the medium. All your mobile phone devices have optical sensors. So that is also part of optical fiber devices or communication. It's very simple. Even everyone, those who are having a smartphone especially, those who are having a smartphone, there will be an optical sensors in that. Of course, it will be having a camera and other optical devices. So you can say best example for communication and telecom, mobile phone. It need not have a cable, but it have optics in that. So that is the one example. Networking applications, yes, in local area or metropolitan area networking, as I said, FTTH is used, fiber to home technology is used. This is very common. I think everybody knows this one. Then sensors, optical sensors are very important. See, optical sensors, why it is used? Because of their high efficiency. High efficiency, even in some of the transducing devices, mostly it is built in and around optical sensing area only. Medical applications, yes, medical applications also we use in some of the cases where non-invasive or non-surgical thing, if it has to be operated on a particular person or a patient. Earlier they used to cut the body and just check the disease or those medical things. But now because of optical or because of fiber optics technology, we have some of the instruments or some of the things, like one of the thing, it's called fibroscope, which is used in medical industries. This is this fibroscope, what it does is it penetrates inside the body in a very hollow areas, very hollow areas. It's extremely thin and it can be transmitted into the blood vessels. It's very thin, and it, you can put it in blood vessels and you can do the investigations on that particular patient or on that particular body. So that will avoid the surgery of a person, or cutting the whole body and checking, not whole body, cutting that particular body part and checking. Instead of that one, just insert with some micrometer hole and insert this fiber and do the investigation. So that is the biggest advantage in medical field. Mostly these things of devices are used, like which I said, fibroscope, which is used in medical devices. In industry, mostly in not only in security, in industry they used for lighting part, and they used it for reduce the what we say, reduce the total cost of their communication. Like if any heavy industry is there, they have their own communication stations. So there, to reduce the long-term cost, they use fiber optics technology only. One best example is, since I'm staying in Hyderabad, I have personally visited. We have here near Hyderabad Mahindra factory, Mahindra vehicle factory, and they have their own communication station, their own tower, their own transmitter, their own receiver, everything their own. Of course, government permitted it is there. When I went there, I saw everything is based on optical fiber technology. Of course, the antennas and other things were coming into RF concept. But up to that point, up to that antenna, everything, the data transmission or whatever purpose they were using, everything was optical fiber. Optical fiber they have used. So when I asked one of the in charge of that particular station, so he said that we use for, as I said, we use it for a long term, as a long term solution. Because if I use a copper or a wired communication, I'm time to time we have to take care of their maintenance. Time to time we have to attend the breakdown. Whereas the fiber optics is error free. Last 10-12 years we are using, not even a single time we attended any technical fault or a technical problems in this. So that one good example which I have given, which I personally visited that factory. Next we'll see. Yeah, I think this thing you may be knowing, but you please remember, the propagation of light in optical fiber, either if it's in a single mode or a multi mode. But the last 2 points, the second and third point, you please remember always when you are choosing or when you are studying or when you're doing a higher study. So this will be your basic. You just keep it in mind that this single mode or a multi mode is preferred for what? It's only preferred. You just focus on that word preferred. It's not mandatory that MF is cannot be used for long distance. It can be used, or it's not mandatory that SMF cannot be used for short. It can be used. It's only the preferred because it's have their own advantages for short distance or their own advantages for long distances. When we see this single mode or multi mode, there are having their own advantages and their own disadvantages. I mean, the best advantages I have listed here is a faster transmission rate over long distance. Why? Because it allows only a single bandwidth of light in single mode fiber. Single bandwidth of light, so the bandwidth will be, I can say unlimited. The bandwidth is almost unlimited. If a single wavelength light, if you are passing, you will obviously achieve unlimited bandwidth. So obviously your the speed will be very fast over long distance. Of course, in short distance also it is fast, but for longer distance, this is a much error free. So that is the reason SMFs are used. As we discussed earlier, the switches and routers required are very less. Since kilometers together, there are no data losses or there are no attenuations in the data. I don't need any switches or routers or amplifiers, couplers, connectors. I don't need anything. The third point is unlimited bandwidth. As I said, it is a single mode, so you can have and you can achieve this one. Data speed up to 10 GB. This is for telecommunication. Whatever example I given is for a telecommunication. For other fields, it may vary. It may be high or it may be low. But for telecommunication, the permitted data speed or a permitted this thing is 1 to 10 GB. As on 2018, it was 1 to 10 GB. Maybe now the data speed might have gone up to, maybe it have gone up to terabytes, but it was 1 to 10 GB in 2018. As it travels the distance, as I said, the loss will be very low compared to the conventional wired communication. And the stability, since it's of 8 to 10 microns and they will be coupled in bundles. The stability is very high compared to the copper cables, because there is no self interference of fiber optic cables. Like one cable will not interfere in the data transmission of its adjacent cable, which is lying on the top, side or bottom. Whereas in copper cable, there is a chances of interference when the data or the information, or can say the signal is the best word, which is traveling inside that copper. If it's of very high intensity, it may interfere its adjacent copper cable. If it's of a high intensity, say high frequency or high power, it may interfere its adjacent copper wire. Because of this, you can see the data loss or data corruption and other kind of faults. Whereas in case of fiber, it's absolutely zero. There is nothing that if they are bundled together, are combined together for the transmission, there is no data loss or there is no these things. It's because they are integrated inside a jack clad as well as a jacket. So there is no thing that the light will come out because see, we have not discussed basic things like light will be inside reflected inside the core itself. So there is no chance that your data is coming out. Whereas in copper, what happens? There is a chance that it will be radiated. It will be radiated out of the wire. Even the outer jacket or outer copper wires, if it's of a high intensity, there is a full chance that the signal which is passing through that cable, it will radiate and it will interfere it to it adjacent wires. Not only adjacent wires, any electronic device which is there near to it will definitely interfere that one. uh, but there is a solution in wired communication, like how we use plaid jacket in fiber optics. There is a solution in wired communication also. There they use Teflon material, a Teflon material to cover this copper wire. A Teflon is a material which never allows any radiation out of its surface. So it will not allow any of high intensity radiation also, it will not affect. So that is why Teflon coated cables are there. Cables will be used especially in RF and microwave communications. If you okay, that's a different technology, but you might be knowing in RF and microwave communication, all the cables are Teflon coated. When you study, if you study antennas or other things, you can see the cables which we use are all Teflon coated. Why? Because the source side you might be using 860 megahertz or 900 megahertz or it's almost I think 960, 860 megahertz data. I mean the signal you use. So they are high intensity signals. So there is a chance that it will radiate out of the wire because of this high frequency. To avoid this, they just put a Teflon jacket, Teflon coating on that particular wire, so that there is no data loss. But that is again add to the cost because Teflon is a costly thing, and when we discuss, I mean when we plan for a long distance, 100 kilometer, 200 kilometer, it's not feasible. So better we'll go for fiber optics this thing only. So there are disadvantages, as I told. It's expensive and additional heat factor because this single mode fiber, the preferred source is a laser. The preferred source is laser, and laser. One of the disadvantage of that is a heat factor. Heat factor in a long distance. So we have to tackle that one. So there are solutions for that one. There are solutions in a long distance. If any heat factor material, any heat factor comes, there are solutions. I will tell you that one. This point I will tell you how we tackle. Yeah. Use again usage. We can use only one laser with one fiber, since it's a single mode. We can use a single wavelength light source. So that is also a disadvantage. And application specific, it's low versatile. Versatile means you can use it for different kind of applications. No, it's only specific applications we can use single mode fibers. You cannot use for all, like I can use for medical. Here versatile means if I'm using a particular single mode fiber in medical application, same fiber I can take it and use in defense applications. No, it's not possible. It can be used only for that medical application because it will be designed for that particular parameters. You cannot use it for a defense or any other telecom sectors or any other sectors. So that is the disadvantage. That is why it is called low versatile and application specific. So if it is used for that only. You cannot use it for other purposes. Whereas multi-mode is versatile, more versatile, and it's not application specific. You can use it for a different application. The thing which are used in a telecom, you can take it out and you can use it in a different. In aviation, you can use it, or you can use it in a construction, or any other industry, or any other industrial applications. You can use it. So there is no such restriction on multi-mode. But whereas in single mode, these are the shortcomings, because these are the industry standards, which I mean industry observations. Generally, we don't see any single mode fibers used in multiple sectors. It is application specific. Maybe in future the design may change, or they may invent something with which we can use in a multiple places or a multiple sectors. But as of now, this is the disadvantage of single mode fiber. Yeah, multi-mode compared to single mode, multi-mode, it easy to use and easy to couple the light. Coupling the light in the sense throwing the light inside the core of a fiber is easy in multi-mode, because it has got the light source which is having many wavelengths. It will conduct many wavelengths, whereas in single mode it will conduct only one wavelength. And alignment tolerances are very large compared to the single mode. Alignment tolerances in the sense, see, when you align the cable, if any fault is there in the alignment in single mode, what happens, since it's a single wave, if any bending or any curve happens because of the fault, then since it's a single wave, the single data it carries, the end result will be a corrupt data only. Whereas in multi-mode, out of so many modes, only one mode will be corrupted. So remaining things will be okay. And also in multi-mode, the chances of these corruptions are very, very less, because of the construction and designs of multi-mode fibers. Their gradings, whether it's a step index or a graded index, depending on that, their construction is such that these kind of happenings, bending or any other faults are very, very less and cost effective, cheaper compared to this thing. And for short distance communication, as in first slide we see the multi-modes are used for short distance communications. Yes, of course, the multi-modes are preferred for short distance communication, because of low cost or speed or alignment tolerances. For short distance, multi-mode is used. We'll see. Yeah, these are some. I think you will study this thing, the types of multi-mode. See, there is an observation that multi-mode fibers are used more compared to the single mode fibers in industries, of course. In industries, so people focus more on multi-mode fibers. Single mode are used less because of their application specific features. Like I can use only for this in a medical field. I cannot use it for this one. Due to that reason, the usage of single mode fibers are less, whereas multi-mode fibers are very high. I can see. I don't know. I remember I read it. It's like a say 20 to 80 ratio. 20 if it is a single mode, 80 it is multi mode. In the range of 20 to 80 ratio, the usages are there. Again, I think you will study this. There are two types of fiber. There is a glass. There is a plastic. Again, glass have its own advantages or disadvantages, since they have a fixed grading of 50, 62.5 or 100 micrometer, whereas plastic have a rigid this thing, and a variety of dimensions are available, not like 50, 62.5 or 100. Yeah. Yep. See, in previous slide, we see plastic is advantages compared to the glass. So the features here, it's a low cost. It's a low cost alternative to glass fiber, or compared to the copper, or we can say wired communication. Up to 10 gigabytes per second data transmission can be achieved if you use a fiber optics multi-mode. Sorry, plastic fiber multi-mode. And fiber optic systems, see, this is made up of special material called PMMA, that polystyrene polycarbonate and polymethyl methacrylate. This PMMA, this is the material which is used to prepare the core of that optical fiber. These materials have transmission windows in the visible range of 520 to 780 nanometer. Okay, see, this PMMA material, if we use as a core in multi-mode plastic fiber, I can have my light source of 520 nanometer to 780 nanometers. See, we have one general light which we see. It's a sunlight which we see in our daily life, like from violet to red. It has got its own particular, see, every color, whatever color are there in that rainbow. It's violet, red, indigo. So they have their own wavelengths. So the plastic fiber multi-mode will accommodate this wavelength range, light into the core, into its core. Also, the loss of light transmitted at these wavelength is very high. It's high, ranging from 150 dB per kilometer to 1000 dB per kilometer. So that is the reason they use glass fibers for longer distance communications. So you can see the loss here is 150 dB per kilometer, and you can see the here is only 0.2 dB per kilometer, but for a single mode fibers, and less than 3 dB for a multi-mode fibers. So hence this is used for longer distance communication. See, there is one thing like nowadays plastic fibers have been relegated to short distance applications, typically like for 200. Generally, you should not use plastic fiber for short distance communication. You have to use it for longer distance communication. But now there is a tendency that because of the cost compared to the glass fibers, people use plastic fibers in short distance communications also. So that is the reason it is said that it is relegated. It is relegated to this thing. Okay. Yeah. Plastic fibers general applications, which is plastic fiber devices. General applications is industrial control. See, on your process, in your PLCs and other things, this is used in automobiles. Plastic fibers are used. Automobiles, how optical fiber is used means. See, the modern cars means modern vehicles which are coming up now. They have airbags, and they have some sensors pre-installed in their car. See, these airbags and these sensors work on optical fiber technology, because these vehicles use optical fiber cable for the data transmission throughout their vehicle body parts for faster transmission of data. See, it's very critical. See, the vehicle is moving, it suddenly get some obstacles or some kind of a crash or something. You have a very less response time to decide what to do. If I use a normal conventional cables, the time taken by the data to travel throughout the sensors and end of the day it comes to the control system to decide, it's high. Whereas in fiber optics, it's very fraction of a second, 1/100th or 1/1000th of a second. It decides what to do. Shall I open this what we call safety this thing, or shall I intimate the owner about his car theft or something. So these sensors uses optical fiber technology. And home networks in the sense, if any buildings or any society is there, they can have their own LAN network by using the fiber optics technology as well. Plastic fiber will be more useful in home networks, and short data links, again plastic fiber will be more useful. In some of the things, non-data applications. See, every time we see fiber optics is there. So what is the purpose of fiber optics? Transmission of data. Data it takes from the source and give it to the destination receiver. But there are some applications where data is not present. You can say non-data. So those are called non-data applications. Like detecting the energy particles, or a signages, or illuminating a building. You can say decorating a building. There is no data is involved. You need a simple these kind of optical fiber cables to make a signages or to illuminate buildings. The more today the surge of POF production and use stems from its using data transmission. Of course, because the more you use in more the data transmission happens, the more we can use plastic fiber this thing. Yeah, advantage. These are the advantages. It's simple, less expensive, lighter weight. We discussed this. Ease in handling, that also we discussed. Is inexpensive. Glass requires a laser as a light. So yeah, one of this last, but one glass fiber requires specifically laser as a light source, whereas plastic can conduct both the laser as well as your LED, your light emitting diode, 860 nanometer or 850 nanometer, 960 nanometer, 1310 nanometer or 1330 nanometer. Yeah, other like immunity to electromagnetic, into that we discussed. It's having a greater flexibility, resilience to bending, shock and vibrations. Because glass fibers, if you try to bend more, there is a chance of a breakage. Whereas plastic fiber, since it's a fiber material, it has got more flexibility. Okay, of course, there is a limit. You cannot bend beyond that limit, but that limit is much that threshold limit is much higher compared to the glass fiber. Okay, see, the thing is, in certain ways, plastic fibers are more advantageous compared to glass fiber, or in certain ways, the glass fibers are more advantageous compared with the plastic fiber. That is why this discrimination. But overall, it's a fiber optic technology only. Whether you use the plastic fiber or you can use a glass fiber. See, there are a disadvantage of plastic fiber compared to the glass fiber. The application research is limited to production. Yeah, because of its application specific reasons, there are no, the fourth point, there are no standards like to follow, that I have to design my fiber like this only, like that. Since it's application specific, you can use it for that only, means okay, you can prepare some standards for that. There is no generalized standards. So that is, whereas in glass fiber we have generalized standards. Even IEEE also has recommended some generalized standards for glass fibers. There is a lack of awareness also for installation. Even of course, we ourselves struggle sometime when plastic fiber has to be installed. We ourselves struggle, how to prepare the installation processes. So there is a procedure involved in installing these things. You have a source, you have a coupler, you have a connectors. You have to remove the jacket, you have to insert the fiber. There are so many things are, I think you will in academica, you will in academy you will study preparing fiber optic installations. Other things such as production is limited because of specific applications, and research is incomplete because we don't know. Research is incomplete in the sense we have not tested it for its extremes till today. Whereas a glass fiber, we have some data in case of glass fiber, but whereas in case of plastic fibers, the research is still incomplete. We don't know what extreme level it works in terms of plastic fibers. Again, certification programs, because of this incomplete research, we don't have any certificate programs. uh, yeah, lack of high temperature fiber. Like if we in high temperature, there is a chances of fiber melting or a bending phenomena happening in fiber systems. This is a small comparison. Just wanted to share. I think in academic also you study like whatever we discussed now. It's just a brief. I've taken some parameters like component cost, how the loss will be, what are the connectors or how the connectors will be, how we can handle flexibility. You can see in some of the things plastic is better, or some of the things glass is better. Again, the source of light, what we can use here. Yeah. See, just before concluding, I'll just share some of the other points with you. Fiber optics, because see, you will be graduating and you will be going, but just try to remember some of the points apart from telecom, medical, these things. Fiber optics are used in so many fields. See, there are optical converters. Optical converters in the sense the electrical signal, which is converting into an optical signal. So optical converters. The best example is optical modems. Some of you might be having, because I am having in my home an optical modem itself. It's not a DSL modem, like regular copper wired DSL, that a digital subscriber line modem, DSL modem. I have an optical modem. So this is also one optical device. This is also an optical fiber device. Because generally when we say optical fiber, we think of only telecommunication, that cable, that medical, one or two things. But I wanted to share some other things, like we have optical converters, and we have vice versa, like from optics to electricals. And we have optical profilers. Optical profilers are also widely used. See, optical profilers basically they do surface study of any metal, surface study of any other chemical, surface study of any other wood or something. Surface study profiling, they do 2D or 3D profiling of that things. So for that you need optical profilers. It's called topography. Topography. It's study of textures, study of smoothness, or a study of it's kind of a calibration of a thing, like everything is smooth there or not, or any curve is there, any alignment is missing in that surface. Like for that you need optical profiler, which is purely an optical fiber device. Other optical fiber devices like interferometers like these are the interferometers where two or more than two light sources are combined, and they study the effect of that combination or that integrations. So interferometers. The resultant study will help in deciding which light source or which source is better for a data transmission or for any other kind of optical transmissions. And we have a optical projector also, that projector which general projector which you see in your this thing. We have optical telescopes, we have optical microscopes, we have optical cameras also. Again, if you go in military, since we supply to the military, there are something called hydrophones. Hydrophones, the hydrophones are nothing but general walkie-talkie phones only, but used underwater in submarine extreme conditions. Hydrophones, they use fiber optics technology only for the communication between two devices. Hydrophones is there. Sonar technology, sound navigation and ranging technology. The sonar technology, they say sound propagates much faster than light in water, of course. But when that data comes back, to analyze that data, I don't have a, I cannot install I cannot say I cannot install, but it's very difficult to install a copper wire underwater. So fiber optics I use underwater for more efficient data analysis of a signal reflected back from the sonar. So sonar is used, or seismic applications, I can say. Seismic applications is earthquake predictions or any extreme bad weather predictions. Fiber optics technology used because of its high data transmission rates. General application like a broadcast application, TV, the cat TV, HD TV, all these things, these are all due to fiber optic only. The other things like fiber connectors, fiber fuses, fiber couplers, fiber splicing units, and these things are uh, equally important while studying fiber optics, because if we study only the fiber part, and if we miss what are the things is required to particularly install a fiber, then will be somewhat incomplete. Maybe it will constitute the 5% of the total thing, but my advice is try to focus on the accessory part of the fibers also. Accessory part of the fiber is also equally important to understand how fiber this thing fiber optics technology works. With this, so I will try to I will end up my session. I hope it was very brief. I'm not sure given you much, but I try to give you just glimpses what is happening in industry, and what is preferred in the industry, what knowledge is preferred in the industry, because these are the knowledge which I have acquired, which is helping me to survive in the industry, and I hope this will help you also. Maybe 5%, 10% if it helps you. So I'll be very happy. And again, once again, thank you all for joining. 40 odd students. Dikshit sir, Gururaj sir, thank you for giving me this opportunity. See, my doors are always welcome. If you have any queries now or later, anytime, if you have query related not only with fiber optics, I think I was discussing with Gururaj sir that recently we started with home automation also. home automation, and we are implementing fiber optic technology in home automation, inside a home automation. So if you have any queries or this thing related with that one, of course you can throw me that query. I'll try to answer it in my own best possible capacity to you. So I will just request Gururaj sir to take over
Yes, sir.
from me. Again, I thank you for the management of the school, college, and Dikshit sir. Again, once again, thank you very much. Gururaj ji, thank you very much once again giving me opportunity. Uh, it was very nice. So, uh, just pardon me if I'm, because I was so excited. Lot of things has to be told in a short span of a time. I tried my level best to give much information to you. Again, if you have any queries in this thing now or later, you can contact me. I can, try to answer that. Yeah, over to you, Gururaji.
Yes. It was a very nice session. Samir sir has given very in-depth knowledge about the basic concepts like characteristics of the fibers.
Sir, one doubt here.
Yeah, sir, please. Samir sir,
Sir, I want to ask that
here,
optical fiber is for remote places, what is the advantage compared to copper wire?
sir, please once say, voice is
For remote places, sir, as sir told, no, for islands and other points, wherein optical fibers are very advantageous other than this copper wire cable. How I didn't got that point. How it is?
I got it.
Yes, sir. Yes,
I will tell you, sir.
Yes, sir.
Yeah, I think Mr. Patil is that the person who is asking
Yes, sir,
this
yes.
question. Yeah. Okay. Why fiber optics is advantageous in remote places compared to copper wire?
Copper.
Because
Yes.
see, I will tell you one example. As I said, I went to Silchar. Silchar is in Assam.
Assam.
Silchar is Silchar. Silchar is having an airport also. It's have its own airport in Assam. See, it's a very hilly area. It's a very hilly area. But surprisingly, if you go and see in every government office or every other offices, technical offices, if you see, they use fiber optics technology. Why? Why? Because uh, the geographical systems or geographical setups is such that you need not go frequently to check whether my system is working or not, right? If you lay a copper cable, there is a 100% chance that there will be a requirement of a continuous monitoring at all the intervals, all the places where it is being laid, say at 1 kilometer level, 2 kilometer level thing. So you will be having increased manpower plus safety of that manpower, because he has to live in that condition. He has to be there 24 into 7 to monitor whether my systems are working. Whether, say for example, for telecom application, you can see I have a tower there. I have a tower and I laid a copper cable to transmit my signal. Of course, the tower will be having trans receivers, both transmitters and receiver. If I use a fiber optics cable, it's like I install and forget it, because it's proven.
Yes.
Yeah, it's install and forget it. There is very low chance that my things will not work. Whereas copper means there is a chance that there is an interference, since the geographical conditions are such that there will be a landslide, there will be a flood, there will be an extreme weather, where copper cable cannot withstand these kind of shocks or these kinds of external factors. Whereas optical fiber is residing inside a clad and jacket, so there is no outside interference. Even something fall on that, something something happen, there is no external interference. So that is the reason optical fiber is preferred. Optical fiber is preferred. But I think, I think Mr. Patil has used. Yeah.
So repeaters and amplifiers are very less number of repeaters and amplifiers used now for optical fiber.
Yes.
So as distance, if it is increased, then whether we can get the signal level at the same. same level signal for a longer
100%.
distance.
100%. You can see in my presentation itself, I had shown that
Yes,
glass fiber, it is
yes,
almost 0.2 dB, and for
yes.
certain distances it was 3 dB. That
Ah,
is acceptable range. That is acceptable range.
what about the scattering loss and this wear and tear, and what about the bending loss, sir?
See, bending loss,
Negligible.
yeah. See, bending loss comes to picture when the
Hmm.
stability is not there. When there is no
Ah,
like whatever the cable you have laid, if it is not stable. See,
hmm.
frequently copper cable, what
Hmm.
they do, they hang it on. They just hang it simply. So there is a chance that it will be hanging, falling down,
Hmm.
going up. Whereas
Yes, sir.
cables are firmly mounted or firmly installed on a particular
Yes, sir.
base or particular thing.
Yes,
It
sir.
will not, it is immovable. The stability is
Never.
more.
Hmm.
So because
Hmm.
of that, the light which travels through the cable will not
Hmm.
suffer any bending loss or any attenuation loss or any other kind of losses
Ah,
for its propagation. That
okay.
is the reason.
Okay. Okay. Thank you for your
Yeah,
valuable
yeah,
guidance
Mr.
in
Patil. Yeah,
all
Mr.
this.
Patil. One very interesting thing which I forget. You told that island
Yeah.
word you have used. Why it is
Island
used as
and
island? Yes, yes, yes.
yes, sir.
No, island will they will not use. Island satellite communication is used. Satellite
Yes,
communication is an alternate to fiber optics communications.
fiber optic. Yes,
Islands
sir.
islands are preferred satellite communication. They never.
Okay.
I
Okay.
have went to Andaman and
Ah,
Nicobar, Port Blair.
okay.
There is no
Okay.
fiber optics
Okay.
there. I mean,
Hmm.
they have their local area fiber optics is there, but
Ah,
there is no fiber optics from mainland. They call mainland
ah,
India as a mainland, though
okay.
it's a part of India. They call a mainland.
Okay.
So there is
Okay.
no cable lying underneath up to
Ah,
this thing. They use a
okay.
satellite communications.
Satellite communication. Okay.
Low bandwidth satellite
Okay.
communication. Remember, it's a low bandwidth satellite communication, low bandwidth and highly insecure. You can tap
Ah,
satellite. You know this frequency. You can easily tap it. Satellite operate
ah.
2.14 gigahertz,
Security is
2.15.
more in fiber optics. Security is more in fiber optics. Okay.
Accurate, yeah. You cannot
Okay.
tap the light. You see, if I
Ah,
get a
yes.
RF signal, I can easily
Ah,
analyze it. I have RF
yes.
analyzers. I have spectrum analyzers. I can easily
Okay.
say what data it is. But if
Ah,
I give a light source, if I throw
ah,
a torch on you, if a light
ah.
falls on you,
You
you
can.
cannot analyze
You
it. What
can.
kind of light
Yes.
it is? What I have to
Yes. Sir.
do? But if I throw
Yes.
a RF signal on you, you quickly
Yes. Sir.
bring one RF detector. You immediately
Yes. Sir.
detect RF signal. This RF signal. This might be
Okay.
a or RF or FM or AM or something like that. In that range, I am
Signal
capable.
tapping is possible. Okay. Sir. In
Yeah,
RF,
yes,
signal
yes,
tapping
very much
possible.
possible. Very much possible.
Possible.
It is
Possible.
nil
Okay.
in fiber optics.
Nil in fiber. That is why security is more. Sir.
Yes,
Security is more.
highly secure.
Okay.
Highly
Okay.
secure.
Highly secured. Okay.
Yes.
And speed is also good. Okay.
Yeah, speed is good because see, single wavelength. If it is traveling, you have a start to end. Entire space is yours. Very simple. I will
Okay.
tell you. Small gully. If you push 10
Hmm.
people to run, they will be
Yes.
doing all pushing each other and going. If you tell only one
Interference.
person to run, he will run fast.
Yes. Sir.
That is the thing.
Bandwidth. There.
Yes, yes, yes,
Bandwidth.
yes.
Yes.
Yeah.
Yes. 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 Okay.
Unlimited bandwidth.
Okay.
Yeah.
Okay. Thank you.
Thank you, Patil.
Thank you.
Thank you, Patil.
Thank you.
Yes, Samir Singh sir will be having a vast knowledge, and he is in this field since more than 2 decades. So, Sir Samir Singh, since
Yeah,
sir,
yeah,
just now the question has been asked by our beloved department alumni coordinator, Paramanand Patil sir.
yeah, yeah.
So he's looking after this all these alumni activity.
Okay,
So
okay, okay.
yeah.
I'm sorry
So
because I thought some of the students have raised this question.
no.
Sorry,
Okay.
because I
Okay,
cannot
students,
make it. Yeah, I cannot make
if you
it.
have any questions, you can ask. Okay, the Samir Singh sir has given the vast information and in-depth information about the Cat6 of the optical fibers, single line multi-mode fibers, and their wide variety applications, as we have seen in the core fiber optics subsets in the final year. So now we are observing there is a difference between what you have learned in theory and now what is available in the outside world. So I hope this has given little bit glimpse on this gap between what we have learned in the some of the first or few modules in the final year, and also a lot more students have joined starting from first year to the final year. So this will be acting like a basic subject for them. Later you are going to learn in your higher semesters. So I'm very much thankful to Mr. Samir Singh Unnu, the director of this wonderful startup company. And he is in this company and knows the plus and minus points. And this he has given today a very good focus on this one of the our communication related field, that is fiber optics devices and applications. So I am thankful to TIDA management, to the principal, to the beloved HOD, and I'm also thankful to our beloved staff members, and very much thankful to all the my dear students who have participated actively, and hope in the future we are going to organize more such communication related, because we are observing very less such communication related things are happening. So this one is going to give some little bit information or focus on that communication related events. Sir Samir Singh sir, very much thankful
Thank you.
accepting invitation in a short time.
Yeah, it's my pleasure. It's my pleasure.
Yeah. In future also we'll try to do some more wonderful things along with the students or staff members or with the departments. And thank you all of you for joining today's webinar.
Yeah,
Paramanand sir, you want to tell anything?
No, sir. No, sir. No, sir. Thank you.
Thank you, sir.
Thank you.
Thank you, Patil sir.
Thank you, sir.